It's time for a video, and I've prepared a lot of this stuff in advance just to try and keep this video as short as possible. In the past, I've made LED lamps based on standard lamp bases. This is a British bayonet cap base, and test tubes. And I've always thought it'd be quite nice if I could 3D print an object that would let me basically, this is the first thing I actually designed for 3D printing, and it lets you take a standard base, slot that in, potentially gluing it, and lets you stuff electronics in here and then pot it up in resin. And I was just thinking I could do that with the test tubes. I could make a special adapter that lets the test tube be mounted directly into one of these lamp holder bases. So I doodled out a design. Let me show you the design I doodled out. I should have actually noted the sizes down this. The design is based on a few different cylinders, if you will. The first one is designed to fit into the actual rim size of this, which is about 25mm. The other one was designed to go down the inside because the standard British bayonet cap holder, it tapers in. And I wanted to continue it down for insulation, so I could put electronics down there if needs be without them shorting out to the metal body. In the case of the Edison screw, of course, one of the outer thread is one of the connections. But with the bayonet cap, this can be grounded because it's the bottom two connections that are live and neutral. However, this was going to be 21mm. This was going to be 21mm here. This bit at the top here was just going to be a rim, something just to make it look nice. I mean, this is the finished object, and it's about 30mm diameter. And there was going to be a hollow core down the middle. The hollow core was going to be sized for the tube, and I measured that originally at 18mm. I'm just looking at some notes. I should have written it on here. So that's this sort of inner core here. But in the end, I did another thing. I also put a slight wedge down here, a slight taper, by basically adding another cylinder with a slight taper. And then I also just, that was to facilitate 3D printing it, because as it builds the layers up, it can gradually build out and then continue up. And this rim at the top, I also put a slight recess down like that into it, just mainly because when the tube is slid in, there's that slight recess. If you glued it and the glue just gooed out the end, it actually hides that. It gives a wee sort of space. I suppose it's a shadow gap, really, isn't it? It looks quite nice. So I used openSCAD to design this. And I've always been a bit apprehensive about getting into the CAD packages, but openSCAD is just perfect. So I don't know if this is going to show up too well. Let's focus down on that. Let's take the exposure off and dim it down a little bit and zoom in. So I'm going to do something that I've never seen anybody else do it before, so it's probably worth a go. I'm going to copy and paste this script here, because this is the script with lots of comments. The actual number of lines, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's 15 actual lines of code in this that create this shape. And openSCAD is interesting because it's based on solid geometric shapes, cylinders, spheres, and cubes. And you can change the dimensions of the cube in any direction. The cylinder can also have different dimensions at the top and bottom, different radiuses, so it can taper or even be a sort of cone. And the sphere and all the other shapes can be squished. They can be distorted by scaling them on each axis. So what this does is it stacks several layers to make up this shape. And if you actually download openSCAD and you go into the description down below, if this works, and you copy that and you paste it into this area of openSCAD, which is a free CAD package, and then you press this little button down here, which looks like a cube with a little egg timer, then after a few seconds, when it's built this, depending on the speed of your processor and your computer, it'll make a sort of ding noise, and then this will appear. And then you can look at it in more detail. You can grab it with the mouse and you can twist it and rotate it and zoom in and out. But the way it's done is it's done in two sections. It starts off with the word difference and then union. I don't know why they stack it like this. It would have been nice if they'd be able to do it separate, but I suppose it means that... No, I don't really know why they do it like that. But it starts off with difference, then an open bracket, and then union. Now, difference means it's going to remove things from the shape. Union means it's going to add things together. So what I actually did was I started adding just like the cylinder, another little cylinder with a taper on it, and then this bit round here, which is actually a sphere that's been scaled, it's been squashed, so it's kind of turned into a sort of rugby ballish type shape, but actually, that's not a good description, a pill type of shape, a M&M type of shape, the chocolate M&Ms. But then it goes down to the next section, and it removes bits. So it removed a core right down the middle to make a hole in it, and then it removed another little section. It removed this little section in here, and that's the ridge. But as I say, this is all down below in the description if everything's worked to plan, so you can try this yourself. I printed it off, and I have to say the first one was a bit of a disappointment. Although I'd measured this accurately, that might just be a slight tolerance thing, the printer. When I tried putting the tube in to the thing, it didn't fit. So I went back and printed another one, which is just a little bit wider, and it does fit perfectly. But while that was printing, to my annoyance, I found the other tube fits perfectly. It just slides in like a slight friction fit right up to the end. I'm just going to take the brightness up a wee bit again just to make this more visible. So this, it really is, it's a nice friction fit here. It works very well. So that's what it's going to be. So this tube can slide in here. This can then go into the lamp base and get glued. And that means I can put circuitry in here, and it's got that nice little base with a sort of flange grip there. So let's start it. While I was doing this, I was trying to optimize the space. I want to get the maximum number of LEDs in. These are actually color changing LEDs. And I've soldered 2 strips of soldering them end to end, and then put a very slight helix in them with them facing each other. And the reason for that is so I can get a sort of, the circuit goes up and then it goes back down, but by facing LEDs towards each other and then twisting that way, the wires aren't going to touch and short out. It doesn't really matter if they do touch and short out, it won't really affect the circuitry. It's current limited. But while I was doing that, I noticed that I'd been very stylish about this rectifier in here to fit these filaments in. So I decided to do the same with this one, and I've created a sort of stylish shape. Let's put this together. So I'm going to start by soldering the capacitive dropper. Oh, that's what I meant to do. Show you the circuit I'm going to use. That'd be a great idea. Tame it down again. It's a simple capacitive dropper. It's got the capacitor that limits the current in each half cycle. It's got a bridge rectifier, inrush resistor, discharge resistors, the smoothing capacitor on the output, which is 4.7 microfarad, 400 volt, a discharge resistor across it, which I've not got, and 2 1K resistors and series the LEDs. The reason for the 2 1K resistors is that if you have an LED, occasionally an LED will go open circuit, and then it will sort of short out again, so to speak. If that happens, the voltage across the capacitor could fly up and it could damage the other LEDs if there wasn't current limiting. So that is why I've done that. Let's try putting this together. Let's brighten the image up again. Is this a good height to be working at? I think it is. So I've made the bridge rectifier. I've already coupled it onto the... I've got that... No, I thought I'd got that wrong. I've not got it wrong. I've got both the positive ends of the diodes going up to the positive connection of the capacitor, and both the negatives going to the negative end. So now I'm going to solder. I should actually put a little bit of flux in this. Where is my flux pen? I'm going to solder the capacitor, the drop capacitor, which I've already soldered the discharge resistors across. So I'm just going to put a bit of flux in that to give it, the flux helps the solder reflow. And I shall solder that onto here, and maybe just twist it into shape afterwards. I'm making this up as I go. You know what I haven't thought about? Oh, I can change that afterwards. It's fine. So let's reflow that. And now thinking about this, I should have angled those down much further, but that's okay, I can do that. It's going to have to fit into the tube, so I'm going to have to angle that down. I'm going to have to try it in the tube, in fact. That would make sense. Oh, yeah, see, that wasn't thought through, was it? I should have tried this before. Not to worry. I'll make it fit with violence. Okay, That's one connection. Hopefully I've not tensioned those solder connections for the next thing I'm soldering, which is the resistor. If I've tensioned them too much, it's going to spring apart. That's okay. We'll work around that if it does. So I'm going to flow some solder onto the end of this resistor. This is a 10 ohm resistor stolen out of another kit, an LED lamp kit. I'm going to add just a wee touch of flux onto that, because once you've, the flux is normally in the solder, and once you've flowed the solder on, then the flux tends to boil off. That's the vapour you see coming off it. So adding a touch of new flux will solve that problem. Did those stay together? I think they did stay together. We're back in action. Excellent. So now I'm going to cut both those leads to roughly the same length, keeping them as short as possible. And I'm going to solder them onto the wires in here. Like this. So they're pre-tinned. I'm going to add a wee touch of flux again, because it really helps. It does. It avoids the solder being quite dry and peaky. And I'm going to carefully solder the capacitor onto that one, making sure I don't burn my fingers in the process. Slight hiss as the flux comes off. This is good. Means it's doing its job, cleaning the surfaces, helping mate the metals. Now the next one, the resistor, making sure this is going to be pointing straight up. Yes, I'll make it. I'll use brute force if it comes to it. That's looking pretty good. Do we try that? Do we just slip it in and see if that's going to work? Yes, it is. So how much space do I have for LEDs? I've got a couple of resistors to go on here. I've maybe been a bit optimistic with the LEDs. Oh, I have been a bit optimistic with the LEDs. Right. Okay, I shall improvise. I shall put the resistors in that first. Let's get this back out. And I shall crop this down. This is, I'm going to be soldering much closer now as originally planning. That's where I also should have put the discharge resistor across and didn't. I'll add it later. Famous last words. Bit more solder. Dab of flux. Just leave the lid off that because I'm going to be using it again shortly. Hopefully this won't ping. I shall add a little bit more solder to that. This is where it does ping. It didn't ping. Still plenty of time for it to ping. That one didn't ping either. I'll just stick the resistor in that one. These are the little resistors that will limit the sort of peak current through the LEDs, the sort of spike current, if the circuit gets broken in any way. Because otherwise they normally clamp the voltage across this capacitor down to probably about 100 volts or so, the number of LEDs I've used. But when it's open circuit, on our mains supply, that capacitor can go up to about 330 volts-ish, which means that when the LEDs connect again, there's a sudden voltage difference and the spike can cause damage to LEDs. I like these lamps because the circuitry is visible inside them. It makes it look quite neat. I guess people don't really stare at the lamps, but I know what it looks like. And I shall solder this one onto here. Perfect. Okay. Now, I think I might be better actually sliding this back on and just seeing where I'm going to have to trim the LEDs. I've got another resistor up at the end that I bridged them together with. I think I'll keep that in place. I want to cram this with LEDs right in as far as I can get it, so I think I might split it here and here. Okay, now which of these is positive? That's the negative. This is the positive. I have to get the right way around, otherwise I'll destroy every single one of these LEDs because they're the type that have the little chip inside them that controls the colour changing. And they don't like being connected the wrong way. It sometimes nukes the chip. So the one that's going the lowest down is the negative, which is there. So I'll crop that lead there and get as much space as possible. Being greedy, we can pretty much guarantee that it won't fit because I'll have tried to get too many LEDs, but it can be fine-tuned if needs be. Dab more flux, and on goes that LED cluster. I've really documented what every bit of that program does, that script that creates this 3D printed object, so that you guys can actually hopefully work out what each sort of thing does. And by doing that, it means that you can fine tune it. If you want to make it on a 3D printer, you can adjust the different parameters, different sizes. That's assuming that it does work when copied from the description area down below. It'd be good to hear from you if it works. Has MD done that before? Has MD included a CAD file in the description without actually a link to somewhere else? Oh, do you know what else I'll put in the description? I'll put a link to an article that I found online that was a huge help in getting to grips with openSCAD. This lamp has just been finished. Okay, I'm not gluing it together right now, but you're going to see it plugged in for the first time, and well, you know, sometimes that can go wrong. I keep promising things are going to go wrong, and they usually end up working. How's this going to look? I'm going to check it over. I've got that one coming to that side of the rectifier, this and the capacitor, 220 nanofarad coming to that side of the rectifier. Negatives are going to negative, positives are going to positive, positives going via the resistor to the LEDs. That should work. I mean, it might not work. Right up to the end. That looks pretty good, doesn't it? Let's bring in the socket and test this. I see a socket down here somewhere. Oh, there it is. It has bayonet cap. It may just go bang. One concern I have, and one thing I might do differently in future, I might include an extra hole down here, a tiny little hole or a couple of them, to allow venting just in case something vents inside, because I suppose the glass could shatter just like an ordinary lamp. Will it work? It's working. Let me take the exposure off and turn the light off. Ah. Now these LEDs are all going to go out of sync. And when they go out of sync, I'll just lock the exposure. When they go out of sync, all the colours are going to start mixing and merging. You can see they're already sort of slopping out of sync. That looks pretty good. I have to say that looks pretty good indeed. Oh yes. That is neat. And you know what? Because I've used a capacitive dropper, it's bright. Now I'm going to bring the hop in and we'll measure the power. So I'm going to unplug the light. I'm going to plug the hop in. And because the exposure is different, the hoppy will look rock solid because the camera is taking longer exposures. The power consumption of the light is a mere, it's 1 watt. Power factor is terrible at 0.337. Current 14 milliamps going in. That is perfect. That is really super low power and it looks great. Not bad at all. Let's bring the light back. So here we have it. That is the project. So the file will be down below. Just copy and paste into openSCAD, which is a free download. And then, as I say, hit that button down there, the one that shows the cube with the little hourglass on it, and that will build it. And when you want to, if you want to tweak it, you can, and then you can see the modifications you've made. And then press STL to get an STL file, which you can then use with your 3D printer to 3D print your own, well, LED lamp adapter. I will say that I'm thinking, particularly for the Edison screw, that I would probably choose to make this bit here shorter so that it doesn't foul against the threads. And I might actually shorten this bit as well. For connection inside, you could either just fold the wire up and trap it against the side, or you could solder into one of the grooves, one of the wires, one of your connections, and get the other one off the back. But it's just thoughts, just ideas of what could be done. Certainly I'm really happy with the way the 3D printing has turned out. It's definitely opening up lots of options for making custom electronic lamps with, well, custom electronics built into the 3D printed housings. But that's nice. There's a strange translucence at the end. I wonder if I had stuff in this test tube. Probably oils and stuff like that by the look of it. Gives it an interesting effect actually at the end. But that's nice. I'm very happy with the end result, particularly the power consumption of 1 watt is nothing for the appearance of this. It looks pretty good. So there you go. Let me know what you think. Let me know if you managed to download that file and actually, well, print one off. So good result. Yeah, very happy with that.